Hi, this is a presentation about router operation, and it's a part of my CCNA2 course. The routing table is where the routers find the information of how to reach different networks, and it's stored in the RAM, and it contains information about the directly connected routes, which is the networks that the router itself is connected to, and the remote routes, networks that connected via other routers. When we look at the routing table and use the show IP route command, we will see that there are different letters in front of the different routes. And there is four different types. We have the local route interface, which is actually the directly connected interface IP address. Then we have the directly connected interfaces, which is the network that it's directly connected to. Then we have the static routes, the ones that we have manually entered into our router, and we have the dynamic routing protocols, which are routes learned automatically, depending on what kind of routing protocols that we have chose to implement. So this is an example of a routing protocol or routing table, show IP route, and we will see here that we have one entry only. It has a D in front of it, which means that if I look in top, I will see that this is an EIGRP route. EIGRP is a dynamic routing protocol, so this is a remote route. It will tell us how to reach 10.110/24. And it tells us that this has a metric, an administrative distance, and it tells us how to go there. So if we look at the specific line, we will see the first identifies the routing protocol, how we have learned the route. This is an EIGRP route. Then it tells us the destination, the pink one. The orange one first is the AD, the trustworthiness of the route. Since this is EIGRP and an internal route, it has an administrative distance of 90. Then we have the metric, which is a huge number in this case because it's EIGRP. And then we have a via address, the next hop. How will I reach this network? Well, I will reach it by going to the IP address 209.165.200.226, which is the serial interface of router 2. Not my local, but on the other side of the link. Then it tells us how much time it has gone since it learned about the network. And then it tells us which exit interface, which of my own interfaces, the router's own interfaces, will I send this information out of. In this case, it's serial 000. So this is a remote network routing entry and how that looks like. Yeah. When I configure a router and set up the different interfaces, for instance, here on router 1, we have 3 different interfaces. Well, then it will automatically appear in my routing table when I do a no shutdown. So after I've configured the IP addresses and do a no shutdown, it will come in to my routing table as a directly connected route. And I will actually have 2. In the newer operating system, I will have 2 entries for each. The first one with the C in front of it is the directly connected network. So this is the network address. It's a /24. And the second one with an L in front of it is the actual local interface, the IP address of the interface. So this here is 192.168.10.1, which is the IP address that I have set up on G00. So 2 entries for a directly connected network. And then when I've done everything, in this case here, router 1 has 3 different networks. Well, then after I do a no shutdown, well, then I will have these 3 entries, actually 6 entries, because each and every one of them will create 2 entries. So here I have the network 192.168.10.0, which is on G00. On G01 I have 192.168.11.0, and on my serial interface I'll have 209.165.200.224, which is the network, and 225, which is my interface on router 1. So these are the directly connected networks. Same thing applies, exactly the same thing applies when I have a IP version 6 address. They will automatically also appear in the routing table after I do a no shutdown and I have entered the IP address. Static routes are routes that are manual configured. Normally I will tell, well, the command is IP route and then the network that I'm going to route to, and then the mask, the subnet mask, and then either I could put in the next hop IP address or the exit interface. If I'm able to do so, it's best to do the exit interface, but because that will involve less routing functionality, because I'll just send it out through my G000 or whatever interface I put up. We normally also use the static route to create a something called a quad 0 route, which is an IP route for all other networks. If I do as an IP route 000 and 4 zeros for the subnet mask as well, this means all networks. So whatever network I don't know what to do with will apply to this rule. And then I'm using this, for instance, if I want to route something out to the internet. Obviously, I don't know all the IP addresses on the internet. So whatever IP address that will need to be routed out will go through this command. So then again, I can do the next hop, or I can do, which is typically to my internet service provider's IP address, or I can just put out an exit interface as well. So this will tell us where to send all information that's not in my routing table. So in this case up here, we will see that we have a quad 0 static route which will send all information to serial 000. So first of all, if I get an IP address into the router, or a packet into router 1, it will look through all the entries in its routing table. If the destination IP address does not fit into one of these, then it will send it out to S000. So all other information will be sent that way. It's called a static default route, or it's also called the gateway of last resort. So if nothing else matches, well, then this will always match. Well, I can also do a static route to a specific network. For instance, here we have 2 different networks with a static route. Now I'm in router 2. So I can reach the 2 networks on my neighboring router. I can put them in statically. And there are 2 different ways. The first one, 192.168.10.0, I can just send it through my exit interface serial 000, and then I will reach it. Or I can put it in, as the second example shows, to 192.168.11.0, and I will go through 209.165.200.225, which is the IP address of my next neighbor, the next hop IP address. So these are 2 ways of doing the same thing. As I said earlier on, the first one is the one that we will prefer. The same thing that we can do for IP version 4 static routes, we can do the same thing for an IP version 6 route. The quad 0 with all the zeros in IP version 4 is quite easy to put in IP version 6. It's only 2 colons. That will do the same thing. 2 colons in IP version 6, and with a mask of 0 will also mean default network or all networks. So this is how you set up a default route in IP version 6. Again, with the exit interface. Or we can also do it with a next hop IP address. Same thing applies here. Yeah, so static routes is when we manually set them up. A dynamic route is where the routers themselves make all this information and exchange information with each other. This is of course easier to set up because you just need to tell them, the routers, which routing protocol to use and which networks to use them on, and then they will start exchanging information with each other. It takes some time to get something called conversion. The conversion means that if a change has occurred, the time it will take before this change has reached all the routers in the network. Some of the routing protocols are fast, some of them are not so fast in converging. These are the ones that we're going to work with in this course. We are going to look at different types of routing protocols. EIGRP is the Cisco proprietary protocol. OSPF is an open standard protocol. ISIS is also an open standard protocol, and RIP is also an open standard protocol. RIP is a very old one, but still a very simple one. Yeah, and you use the command router, and then for instance router RIP, router OSPF, or router whatever you would like to configure. Yeah, so if we look at an example here, this is an IP version 4 example, where we can see that here we are using EIGRP because we can see that there is a D in front of our routing entries. You will always get the explanation on top if you do a show IP route. It will tell you what the different letters mean in front of each of the entries. The same thing applies for IP version 6. Well, then we have 3 different protocols that we can use. RIP for version 6, which is called RIP-NG for next generation, OSPF version 3, and EIGRP for version 6, for IP version 6. Use the IP version 6 router and then a question mark, and it will tell you which ones that are supported by the iOS. And it will look something like this if we have the setup with IP version 6 instead. Do a show IP version 6 route and it will tell you which IP addresses and which networks that we are connected to. Yeah, and that was it. Thank you.